All right, so I'm going to try this. Hopefully it'll let me flip-flop back and forth. All right, so I've got y is greater than 4x minus 1, and I've got y is at the same time less than negative 2x plus 3. So we're supposed to graph the feasible region. The feasible region is the overlap. Okay, it's the overlap that both places share. So here's what we're going to do. We are going to graph the first one first. So it crosses at negative 1, and then I got a slope of 4. So here's negative 1, and then 1, 2, 3, 4 over 1. And I know it's a dotted line, okay? So I am going to graph this way. Oops, sorry. Dotted line. There we go. All right, and y is bigger than that, which means I should be shading everything up in here, because that's where y is bigger. Okay, so I just kind of look at this as a boundary right there. On which side does y have bigger values? Y has bigger values above my pen. Okay, so now let's try it again. I've got negative 2x plus 3. So I've got 1, 2, 3. And then my slope is negative 2. So negative 2, 1. And then I'm going to graph that one. And so it's dotted. So I have this dotted line going through here, and it says y is less than that. So I'm going to shade everything under that. And now you can see that this part in this area has been overlapped. So that's the feasible region. So whatever the overlap is your feasible region. So let's go over here. Let's make you smaller. There we go. All right, so we have the first line is dotted. I'm at negative 1. And I'm going to go up to 4. So 1, 2, 3, 4. Oops, sorry. That was a lie. Here we go. All right. So that's the first one. Don't shade anything yet. So now we are going to, I just clicked everywhere till it stopped highlighting it. And so now I'm going to do another line. I'm at positive 3. And I need to drop down right 1. And so now this is why I drew a rough little sketch, because the overlap is going to be this part over here. So I'm going to grab this and hit the overlap. I don't want to do this part or this part, because only this part, which let's try 0, 0. 0, 0 is in that shaded part. So is 0 bigger than negative 1? Yes, it is. Is 0 smaller than 3? Yes, it is. So I have graphed the correct spot. And so that's going to be the challenge on just these last few, is going to be, let me see if I can, there. Oh, look, it's my head. All right, there we go. All right, so I'm going to use intercepts on this one. Okay, so I've got x plus y is greater than or equal to 4. So if I zero out x, I'll get a 4. So 0, 4 is on the graph. If I zero out x, I'll get a 4. And it's a solid line. Okay, if I zero out y, I'll get a 4. Okay, so this one is on there as well. So now I need to do the same thing with 5, just be very, very careful. If I zero out x, y will be negative 5. So y will be negative 5. And if I zero out y, x will be 5. So I have this one. Okay, so I have two big x's, or I have a big x, okay, and I need to figure out where to start shading. So I know on this one, 0, 0 is a valid point, so I need to shade under the blue line, okay? What about 0, 0 on the other one? I need to shade above the yellow line. I need to shade above the yellow line, except for that's not right. So I would shade below it. Okay, 0, 0 works for the top one. 0, 0 does not work for the bottom one. Okay, so let's try a point in this area. Let's do 5, negative 3. So 5 minus 3 is less than 4. That's beautiful. 5 minus negative 3 is bigger than 5. So this is the area that we want to shade. Okay, so you just need to grab test points in there, But if you think about it, you've got 1, 2, 3, 4 areas that you could shade. So it just kind of helps to kind of sort of wheedle it down so you're not grabbing test points all day long. Okay, so both of those are supposed to be solid. There we go. All right, so I have x plus y is less than or is greater than or equal to 4. So again, I'm going to use intercepts. If I zero out my x, y is 4, and it's a solid line. If I zero out my y, x is 4. Okay, so I know that this is the correct answer, and I also know that, well, let's just keep going. X is less than or equal to 1, so this is a vertical line that slices through the x-axis at 1. So I've got 1. There we go. Okay, so I've got x needs to be smaller than 1. So I would be shading to the left of there. So I've got 2 areas to consider. I don't need to consider these because x is bigger than 1. So I'm going to grab 0, 0 and see if it works. Okay, is 0 plus 0 bigger than 4? No, it's not. Okay, so grab something up in this area. So let's grab 0, 8. So is 0 plus 8 bigger than 4? Yes. Is 0 smaller than 1? Yes. Okay, so that point up in this area satisfies both of them, so that's your feasible region. Okay? All right, let's do another one. All right, these could be intercepts, but they're nasty, so I'm going to rewrite. I've got y is less than negative 4x. Okay, so I've got y is less than negative 4x, positive 5. And then I've got negative y is less than, so I'm going to write this down here. Negative y is less than negative 4x plus 5. So on both of them, all I did was subtract 4x. Okay, but this one needs some help because I need to flip all my signs. So y is now greater than positive 4x minus 5. Okay, so I can graph both of those lines. So again, for each one, all I did was subtract 4x. But on the bottom one, that left me with a negative y is less than negative 4x plus 5. So I changed all the signs and flipped my inequality. So my inequality is now greater than. All right, so what do we have? The top one is, I have a y-intercept at 5. These are both dotted lines. Y-intercept at 5. And then my slope is negative 4, 1. So I'm going to drop down 1, 2, 3, 4 over 1. Okay? And then if I were shading at this point, I would be shading on this side because y is smaller on this side of the line. Okay? On this one, I'm looking for a negative 5, dotted line, and then my slope is positive 4. So I need to go up 4 over 1. Okay, and I know that y is bigger than that. So I'm going to grab 0, 0. I'm pretty sure 0, 0 is going to work on both of them. So is 0 plus 0 smaller than 5? Yes, it is. Is 0 minus 0 smaller than 5? Yes, it is. So I picked that point. So everything in that region is going to work. Okay? And now we go to 11. So I am going to plot the first one with intercepts. All right, so the first one is a negative x minus a y is less than or equal to 5. So I need a solid line. If I zero out x, that means I've got 0 minus y is less than or equal to 5. So y would have to be negative 5. Okay, change the sign. So 0, negative 5 is on that line. Plot, I said. 0, negative 5. If I zero out y, then negative, negative 5 would equal 5. So I need a 5 here. So I just graphed, using intercepts, I just graphed that other one, or the top one. On the bottom one, I think it's going to be easier to put it into slope-intercept form. So in slope-intercept form, I will have negative y is less than or equal to, and then negative 2x plus 3. Okay, negative 2x plus 3. Change all your signs. So y is greater than or equal to positive 2x minus 3. So my other line is going to be negative 3 and then positive 2. So I go up 2, right 1. So now I need to find points. Okay, so for this one, y is bigger than that. So for the yellow line, I know I would be shading above. For the yellow line, I would be shading above. So my options are either this area or this area. So I'm going to grab 0, 0, see if it works. Is 0, 0 less than 5? Yes, it is. Is 0, 0 less than 3? Yes, it is. So that area is going to work for both of them. Okay. And then we have number 12. All right, so your feasible region on this one means that I am making this stuck into quadrant 1. Okay, so look at this. X has to be positive and y has to be positive. So I'm only interested in this thing existing in quadrant 1. Okay, so on the first one, well, on both of them, I'm going to use intercepts. And I'm not quite sure how to do this. Hang on. Do we have... How do we do this? I don't know. Okay, so we're going to learn. We have x plus 3y is less than or equal to 9. So on the first one, I'm going to zero out x. I'm going to find out that y is 3. So x is 0, y is 3. Okay. And I am going to do the same thing for y. I'm going to zero out y and find out that x is 9. Zero out y and x is 9. Okay. Oh, I know what we can do. Okay, so on the second line, 3x plus y. So I'm going to zero out x. Y is 9. Okay, zero out x and y is 9. And then zero out y and x must be 3. Okay, so we're going to have to go ahead and graph these two just so that we can define that we're stuck in quadrant 1. Okay. So I need to verify that I'm in quadrant 1. Otherwise, it's going to shade everything. So I need to create a boundary. So again, I'm only interested in quadrant 1. Okay. So I'm going to grab the point 1, 1 and see if it works, because that's in quadrant 1. Bearing in mind, I only had to graph this and this so that I would have boundaries for the fill. Okay. So I'm going to grab 1, 1. Does 1, 1 work? 1 plus 3 is less than 9. 3 plus 1 is less than 9. So this little area right here is where I'm filling. So if I fill that, it just fills the part in quadrant 1. That's all I need to worry about, is filling the part in quadrant 1. So you're going to have to graph the vertical line, which is the y-axis, and you're going to have to graph the horizontal line, which is the x-axis. And that way it won't fill in everything under here. Okay, look at me figure that out. All right, so last one. All right, so we have Joyce is a marketing director for a new company selling fashion collection for young women. She wishes to place ads in 2 magazines, Magazine V and Magazine E. So we have Magazine V and Magazine E. Okay, what else do we have? Joyce estimates that each one-page ad in Magazine V will be read by 1.7 million people. Each one-page ad in Magazine E will be read by 1.4 million people. Joyce wants to reach at least 8 million people. Okay. And she wants at least 2 ads in each. All right, so here's what we've got. X is going to represent V and Y is going to represent E. All right, so first of all, notice this. We would really like to set this up in standard form, but the way that the software is showing it to us, we're not going to be able to do that. So let's make this bigger. All right, so what we have is this. I have 1.7 x's, so 1.7 million of x plus 1.4 million of y needs to be bigger than or equal to 8 million readers. I want this to be bigger than 8 million, but it can be 8 million. Okay, So because they took it from standard form, which is the easiest way, but they want us to put it in slope-intercept form, I need to solve for y. So I'm going to subtract 1.7x from both sides. I'm going to get 1.4y is greater than or equal to a negative 17x plus 8. I'm going to divide everything by 1.4. So that gives me y is greater than or equal to 1.7 divided by 1.4 is going to be, go to 2 decimal places. So negative 1.21. So negative 1.21 x's. And then 8 divided by 1.4 is going to give me 571. So plus 5.71. So that is in slope-intercept form. Now the other thing is that I want 2 adds in each one. So magazine V, which is an x, needs to be bigger than or equal to 2. And magazine E, which is y, needs to be bigger than or equal to 2. Okay, so when we go over here, let's plop this thing down. I need y to be greater than or equal to, I said greater than or equal to, greater than or equal to, and I got a negative 121, x plus, I've got 571, and then what do I have for? X must be greater than or equal to 2, and then y must be greater than or equal to 2. Okay, so when I check all that mess, yay! Now, we don't have to graph it, thank the Lord. All right, so what we need to do is realize that x needs to be bigger than 2, which means I need to shade to the right of my vertical line. Y needs to be bigger than 2, which means I need to shade above my horizontal line. And then the rest of it kind of falls into place. Okay, so this is going to be the only one where it's also bigger than that line, because I want my y's to be bigger than this part. So this is going to be the only graph that satisfies that. Okay, so and what did I do? I looked at the lines first. Okay, and there you go. I will see you in 7.3. How do I stop?